Hey guys, welcome back to another Leetcode problem solving tutorial. And in this tutorial I'm going to be showing you guys how to solve this problem, merge two sorted lists, where essentially you're given two sorted lists in the form of linked lists. So these aren't just regular arrays, but these are actually linked lists, and it wants you to return the singular sorted linked list which has just combined these two. So this is marked as an easy problem. However, you should know that most linked list problems aren't actually as easy as other easy problems. So linked list problems, I definitely say these easy problems aren't the same caliber of easy as other ones, but nevertheless I'm going to show you guys how we can actually implement this. So first thing I'll do is just get our definition for our linked list. Nice stuff. And yeah, so let's think of some ideas. Okay, yeah, so what we have are two linked lists. Let's go over here and just write them out. So let's say this is our example 1, 2, 4 and 1, 3, 4, like so. Now what we want to do is we want to start off with the smallest element. So for now we'll just assume that the first element in nums1 is the smallest element. So assign list 1, we'll just assume the smallest element, first element in list 1 is the smallest element. And now what we need to do is we need to compare the next element in list 1 or the element in list 2. So we have a choice between either this one or this one, and we choose a lower of the two because we want to get this in ascending order, so we need to choose the lowest items when we can. So when this is the opposite list, let's say we're storing this in a temp variable. So this entire thing is in a temp variable, remember that, and when we want to take the next item from the other list, what we need to do is we need to basically swap this pointer from instead of pointing to 2, this is now going to point to this. So now if you imagine our linked list is this entire thing, and we've essentially lost all of these data, so we need to store them in a temp variable. And remember how we were storing this in a temp variable before? Well, now that's no longer necessary because this pointer points over here, and we can now store this part in a temp variable. So once we've got to that, we'll increment our sort of pointer, and yeah, we'll be on this element. So from here we do the same kind of check, and we're just going to check either the next item in the same list, or we check the next item in a temp list or the other list. And you can see 2 is actually smaller than 3, so now what we want to do is cut off this pointer and go over to there, and now you can see this is what the list is going to look like, but we've now lost the elements over here, so we need to hold these in a temp variable. And remember that now that these have been remapped, there's no need to hold them in a temp variable anymore. Okay, now we're at this counter. We compare this with this element, and obviously 3 is actually going to be smaller, so now again we cut off this and remap over to there, and now there's no need to store this in temp anymore because it's being mapped to by the main list. So we can remove this temp, and we now want to store 4 as a temp variable. Carry this on, so we're at this now. We now compare 4 and the other 4, they're both the same. What we'll say is if they're the same, we'll just stick with the current list since it's easier. So we just increment along here and we get to this, still holding this in temp. And then once we've done that, well, we can do something like we can just map this over to here. So that's it, and we've managed to store our final list. So it's a bit confusing, but our list is going to go just like this, so down, down, and then like so, just like that. So how would we implement this into a linked list sort of context? Well, first thing with linked list is you should usually deal with the edge cases. So edge case is probably going to arise if either of these lists are empty, and you can just check that. So if list 1 is empty, so list 1 if that's equal to, oh, hang on. We don't actually have to check that because, oh no, the number of nodes can be 0, so yeah, it can be null. So we just need to check if list1 is null, then we can literally just return list2, since this is just going to be empty, so sorted one's just going to be list2. And same sort of thing with list2, so check if they're empty first, dealing with an edge case. And you might have remembered that we need to assume that this original list1, we need to assume that list1's first item is lower than list2's. So if this isn't the case, then we're just going to call the function again but swap the two lists. So if the first item in list2 is actually less than the first item in list1, then we're just going to swap the list and call list2 as list1. Just so from here we can always assume list1, first element in that is always lower than or equal to first element in list2. Okay, and now we can start. So let's just, I guess I'll just draw it out again, just so we can have a fresh template. Okay, so currently at the start we're just going to have this list as our main list. So I'm going to create a variable. You don't actually have to do this, but this is just a bit easier. I'm going to create a variable, and this is just going to be list1. So this is our main one, and we're also going to create a temp variable, which is list2, which you remember storing things in a temporary, just so we don't lose them completely. So this is what I'm just going to do using different variable names. You don't have to do this, and it might save you memory, but it's just easy to keep track. So we also need to use a pointer, and this is what's going to allow us to iterate through the list. So we let current be equal to list, and then to iterate we just do current equals current.next. This changes current. But this isn't actually going to change the original list unless we assign this to none, in which case it will, but that's fine. And okay, I think I need to specify that this can either be a list node or null, like so. Okay, and now what we can do is we can start. So I'll just leave this empty for now, but we will come back to this condition. So what we're going to do is, we're currently here, we need to compare the next element in the current list or the first element in the temporary list. So if the current.next is lower than or equal to, and let's just force summarize this for now, if this is lower than or equal to the temp list dot value, next dot value, then in this case we don't actually have to execute any swaps because this is lower than this, so you can just write no swaps required, and we just increment current. So we do the trick, current equals current dot next, like so. And okay, yeah, these type things again slightly annoying, but I'm just gonna keep force unwrapping it just so we can actually ignore them. So this is how we do it. We just increment it and we keep temp exactly the same the next time. Otherwise we need to execute a swap. We need to execute a swap, and a swap is basically where we swap this pointer from pointing there to pointing to temp and then store this as temp. And this is easy enough. If we use the notation of don't know what you call them, but essentially if we use JavaScript's multiple variable at once assignment operation, then we don't actually have to create a temp variable as we reassign things around, and it's just kind of swap them. You might have noticed if you have two variables, A and B, if you just do something like this, this isn't going to work because A gets set to B and then we're setting B to itself. So this isn't going to swap them around. But if we use this, then this will swap them around, no problem. What is the issue here? Okay, I think I need to specify this as a number, but you get the point. That's the idea. So what we can do here is I can do current.next is equal to current.next, and we're going to reassign temp, and we're going to reassign current.next to temp, and now temp is going to store current.next. Okay, and I'm just going to force unwrap all of these, just so, what's this? Okay, let's specify this is list node. Okay, there we go. So what we're basically doing here is we're setting the next to be equal to the temp, and then just get all of this, and then we also just reassign the temp to all of that, all in one line, so it's nice and simple. Okay, so that's the basic idea of the code, but now we need to think about our conditions. So notice how we're trying to access current.next. So what's gonna happen if, let's say we're here and current.next doesn't exist anymore, like there's no current.next? Well, in that case, that means we need to use temp, so we just need to assign to temp. So we can only increment by 1 if current.next is not going to be, if current.next actually exists. So we can check that. We can just use if current.next is not equal to none or null, and then we just use an AND condition here as well. So that's going to ensure current.next always exists, and then we can access it like so. So that's ensuring that, and then come back to this while condition. Well, this is going to have to repeat until either the temp gets fully used up, because at that point, either until temp is not equal to none. Sorry, I keep saying none. There should be null. And also, the current list is not equal to null, because if the current list is null, that means current's been incremented and there wasn't any temp. So that means current's been incremented and there still wasn't any. Yeah, there wasn't any items left, so we can just do current is not equal to null. We might be able to get away with ignoring this condition, since if temp is null, then it's going to get put over to there, and then this would get assigned anyway. But okay, yeah, so this is fine. This is the condition we need. Just checking both lists are non-empty, and then we're swapping if required, otherwise we don't. That's the basic idea. And then from here, I can't remember if what's the question actually? Yeah, so it doesn't actually want you to return anything, because we have now edited head through current. So that's the idea. Current is pointing to list 1, which points, oh sorry, it does want you to return something. Yeah, so we can now just return list like so, because current is used as a pointer for list like so. So that should work. Let's see, I have an error. Oh, okay, it's just from here, so that's fine. So yeah, this should work. Let's now see how this is going to get along. Okay, there we go. So we managed to get a decent runtime, 77.49. Memory not the best. We're in the lower batch. You can see some of these solutions. Let's just have a look. They're sticking with list 1 and list 2. So like I said, using all these extra variables, they do contribute to memory, but it's fine since it's to understand the idea, and it's quite easy to reduce that. But yeah, hopefully you guys understood the main idea of this. Essentially, we go through, check if the next item is lower than the first item in the other list. If it is, then we just increment this, and if not, then we need to execute a swap and then swap the temp list to store this. Thanks for watching, and I'll see you guys in a future tutorial. Bye.